Have you ever wondered, why do some pool toys sink while others float? Today we will learn about all of this and more with my soap monster experiment. Hi everyone, I'm Emily Calandrelli, MIT engineer and host of Emily's Wonder Lab, and on my channel we learn about all things space and science. So grab your soap and let's start floating.
Emily's Science Lab, stay curious and keep exploring. Emily's Science Lab, stay curious and keep exploring.
When it comes to sinking or floating, it all has to do with density, the amount of mass per unit volume. When a toy sinks, that means it is denser than water. It has more mass per unit volume for the same volume of water. When something floats on the surface, it means it is less dense than water. Today we will use the power of density to play with a very special type of soap that is known as the soap that floats. For this one, what you need is a bar of Ivory soap, a microwavable plate, and a microwave. But first, I want to show you why this is called the soap that floats. That was a big marketing hook for the bar of Ivory soap, because when you use the soap in the bath, you don't have to fish around on the bottom to find it, because it floated. But why does it float? Well, Ivory soap has a lot of tiny little pockets of air throughout, and that allows it to float on water, because that makes it less dense than water and less dense than other bars of soap. Now let's see what this looks like when we put it in the microwave. We're gonna go ahead and put it in the microwave for 90 seconds. Now what's happening here is the microwave is heating up our Ivory soap. And remember how I talked about how Ivory soap has a lot of little air bubbles in it? Well, all of those air bubbles are getting heated. And when air gets hot, it wants to take up more space. The other thing that's happening is the soap is getting warm too, which makes it stretchier. So those air bubbles are expanding and our Ivory soap is getting whipped and wavy. And we'll see when it comes out, it'll look beautiful and cloud-like, and it'll make your kitchen smell really good and clean. This is a great experiment. So make sure you're watching inside your microwave as this happens, because it grows like a little soap monster and looks absolutely incredible. You may not need all 90 seconds, so go ahead and check out this soap monster. Look how cool that is. That looks so whipped and wavy and so good you kind of want to eat it, but don't do that. It's still soap. So all of those air pockets inside of our soap got hot and expanded. And the soap was so hot and flexible that it allowed it to get this whipped, wavy texture. And you'll notice as the soap cools, some of it is going to condense, because remember those air pockets, those are getting colder now. They want to take up less space. So it'll get a little bit smaller as it cools. And you can still use this soap. This soap is still good to use in the bathtub or to wash your hands in the sink. It's still soap after all. So now, let's go ahead and touch it. You can go ahead and play with this. Look at that. And it's so light and airy. It's so much fun. Break some of your fluffy soap off and put it back in your water to see what happens. Do you think this will float more or less than it did before? Let's try it out. Do you see how now it's floating on top of the water? Before, the bar floated right at the surface, but now it is very firmly sitting on top of the water. Why did that happen? Well, those air pockets expanded, making our soap less dense than it was before. Now it is more whipped and airy, allowing it to float on the surface of water. Thanks for making Soap Monster with me. If you like this one, be sure to check out my best-selling books, Stay Curious and Keep Exploring, for 99 more science experiments. I'm Emily Calandrelli. Subscribe for all things science and space. And remember to stay curious and keep exploring. I'll see you next time.
Emily's Science Lab.